Welcome to week 10 at Franklin. Radical expressions, solving equations and simplifying expressions. Again, vocabulary review. When we solve, I'm asking you to tell me what value for x will make the original equation true. We talked last week about radical and exponential equations. The deal there is anything under a radical with index n is the same thing as that value raised to the 1 over n exponent. So your radical expression is the one with the radical in it. Your exponential expression is the one with the exponent. So switching back and forth between the radical expression and the exponential expression is what you can do anytime you want, and you can choose whichever expression makes solving the problem easier for you. Okay, week 10 is nice because it's a compilation of a lot of skills you've already learned. So here we go. Past skills you need to remember: how to add, subtract, and multiply fractions, how to factor to solve a problem. When we factor, we rewrite something as multiplication. That's what the word factor means. If we have x squared minus 3x minus 10 is the same thing as 0, you are the mathematicians now that have the power to rewrite the expression any way you want, so long that it has the same value. The quantity x minus 5 times the quantity x plus 2, this right here, has the same value as this expression right here. So you're allowed to use whichever one makes your problem solution, finding the solution, easier. If we factor, we can use the zero product property that then says, okay, if things multiply to be 0, then one of those things has to be 0. So either x minus 5 is 0 or x plus 2 is 0. From there, you solve each of those equations, and that's how you see the two possible answers to the original equation are when x equals 5, or when x equals -2. Again, you have the creative license. You can do whatever you want to both sides of an equation anytime you want. If you're given an expression, you're only allowed to add 0 or multiply by 1. But in this case, I added 5 to both sides of that first equation. I subtracted 2 from both sides of the second. So that's how we know that either x equals 5 or x equals -2 would be the solution to our original equation. So that skill of doing the same thing to both sides of the equation anytime you want is the skill you're going to use with solving radical and exponential equations. You need to remember from week 6 and 7, factoring here, the perfect squares, the difference of two squares. And here we go for solving. Inverse operations, adding and subtracting are opposites. Multiplying and dividing are opposites. Squaring and square rooting are opposites. So the nth power and the nth root are opposites. If I have x squared equals 16 and my goal is to isolate the x, what I choose to do to both sides of the equation is take the square root. The square root of x squared is x. The square root of 16 can be 4, and it can be -4. So there are two solutions. What we look for here is the principal square root, so we generally take the positive. If we're writing on our paper, we'll tend to write x equals plus or minus 4. And this situation here would represent that there are two different solutions. Listen to the directions, read the directions in Alex. Alex might want you to separate the two possible answers with a comma. All right. if it's the nth power, different problem. If I have the fifth root of x equals 2, what's blocking my goal of having x by itself is that fifth root. So I'm going to raise both sides of the equation to the fifth power. The fifth root of x to the fifth is just x. The right side is 2 to the fifth power, which 2 times 2 times 2 times 2 times 2 would be 32. And certainly you can plug that into your calculator. So that means if x is 32, then my original equation would be true. All right, our goals for this week. Solve equations. We're going to solve equations that have radical expressions in them. We're going to write exponential expressions and radical expressions that are equivalent. So if I have x to the 2/3 power, we need to remember that the denominator is the index and the numerator of 2 is our exponent. The exponent is always the numerator. The denominator is always the index. And so you need to know how to rewrite these and go back and forth and use whichever form is easiest for you. Solve for x, okay, on your final, when it says solve, that means, hey, you're going to find the number for the variable that makes this true. That means we're giving you an equation. That means you can do whatever you want to both sides of the equation. If there's more than one solution, separate them with a comma. If there's no solution, then click no solution. So the opposite, I'm looking at this cubed root right here. That's my problem. I need x by itself, so I'm going to choose to cube both sides. If I rewrite it on my paper, I would have the cubed root of x is the same thing as 3. I want to get rid of cubed root, so I'm going to cube both sides. Left side becomes x. 3 times 3 is 9, times 3 is 27. Product rules. If you're multiplying, the bases are the same, then you add the exponent. Your quotient rule. If you're dividing and the bases are the same, then you subtract the exponents. Your power rule is when you have an exponent raised to an exponent, that is when you multiply your exponents. Those are the same thing. The only difference now is these m and n will be fractions. So if I have the square root of x times the cubed root of x, I can rewrite that as x to the 1/2 power times x to the 1/3 power. Again, you can pause the video and go back if that's not clear yet. Here's the thought bubble. The thought bubble is if I have an exponent in the, it's a fraction, I can rewrite it as a radical. So now in this case, I'm adding x to the 1/2 plus 1/3. Might need scratch paper to do that. 1/2 plus 1/3. Rules of fractions. When you're adding or subtracting, you have to have the common denominator. Between 2 and 3, I'd like to have 6. I'm not allowed to change the value of this expression, 1/2 plus 1/3, but I can change how it looks. So I multiply this first term, 1/2, by the value of 1, written as 3/3. So now I have 3/6 plus 1/3 times 2/2. 2/2 is just 1 in disguise. So 1/3 times 2/2 is really the same as 2/6. 3/6 plus 2/6 is 5/6. So my answer here is x to the 5/6 power. If Alex is asking me for the radical instead of the exponential, then my 6 is the index, and the 5 is the exponent. Pause the recording if you need to. Again, I'm multiplying. I chose to write my expression with exponents instead of radicals. My bases of x are the same, and I'm multiplying. So this power rule we learned back in week 5 says I can add the exponents. 1/2 plus 1/3 is the same thing as 5/6. So x to the 5/6 power is the same thing as the 6th root of x to the 5th power. So these two here are the same. Same works for the quotient rule and the power rule. All right. Here's how we are going to use all of this cool information. We're going to simplify this radical. Okay, these are square roots. So I'd like to find the perfect squares. So that means what is 1 squared, 2 squared, 3 squared is 9, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared is 144, 13 squared is 169, 14 squared is 196, 15 squared is 225. That's our 15 squared. And then if I have 25 squared, that number is 625. These are our perfect squares. These are numbers that are very helpful when we're working with radicals. So I have the square root of 98 and the square root of 32, and they're clearly not perfect squares. So the next best thing is, can a perfect square divide 98? And the answer is yes. 98 is the same thing as 49 times 2. 32 is the same thing as 16 times 2. So again, you have creative license to rewrite this expression of -2 times the square root of 98 plus the square root of 32 is the same thing as -2 times the square root of 49 times 2 plus the square root of 16 times 2. Again, 98 is the same as 49 times 2. 32 is the same as 16 times 2. A reminder from last week. Order of operations says if we're multiplying or dividing under the radical, we can do the radical first for each factor, or we can multiply first. Same thing when we have a division situation. So you have creative license to choose whichever of these is easiest for your particular problem. In this case, instead of having 98, I find it more helpful to have 49 times 2. So now I'm looking at -2 times the square root of 49 times the square root of 2 plus the square root of 16 times the square root of 2. Quick reminder, when there is a number next to the radical, the operation is always multiplication. So that's -2 times 7 times the square root of 2 plus 4 times the square root of 2. And again, we're using the principal square roots. So when we take the square root of 16, we'll take the positive version. So 4. Square root of 49, take positive 7. So now what I'm looking at here, I have -14 times the square root of 2 plus 4 times the square root of 2. So this original expression that they gave us is synonymous to, or the same as, -10 root 2. And I will write out what they originally gave us without all the color. They gave us -2 times the square root of 98 plus the square root of 32. And they said, can you make this more simple? Can you simplify this? All right, if you have questions, let me know. Again, by this 10th week, you need to know that solving an equation means tell me all the values for x that make the equation true. So here we go. We're going to do the same thing to both sides. We're going to simplify. Now, when we're dealing with radicals or absolute values, you always want to check your answer with the original equation. We'll work it down to have two possible answers, but then you need to make sure, two caveats, we can never have a 0 in the denominator. And you know the other thing we can never have in the real number system? We can never have a 0 in the denominator and never a negative number under a radical with even index. You're not allowed a negative number under a square root. Or any nth root when n is even. So 2, 4, 6, 8. All right. So never a 0 in the denominator and never a negative under a radical. All right, solve for W. When you take the final, figure out what the directions are saying. That means, okay, if I'm solving, I'm looking for what's going to make that original equation true. I have creative license to do what I want. I'm given the cubed root, so the opposite of cube rooting is cubing. Now, if you prefer to write this as W to the 1/3 power, you can, but you don't have to. Either way, you're going to cube both sides of the equation. And either way, you will end up with W is 2 cubed, or 2 times 2 times 2. Final answer. Now, here's an example from our discussion. I picked a hard one. Should have enough space. I have to put some extras in there. All right. Isolating the x. Actually, let me leave this up so you can see if you need to. Go ahead and write this problem on your page. I'm going to have the square root of x squared minus 8. Now, when you're typing, make sure that you hit the space bar or the right arrow key to get out from under the radical, because whatever is under the radical is under the radical. You can't just, anyway, just be careful. Make sure you write what you mean and mean what you write. I have isolated the radical. Okay, so they gave me that to begin with, but when we solve these, we will isolate the radical. Step 2 is do the same thing to both sides to get rid of the radical. So if I have a square root, then I'm going to choose to square both sides. Now notice on the right, I put parentheses around this, so I recognize this whole thing is being squared. So go ahead and write down what the answer would be there. If you're writing along, you're going to be putting it in your long-term memory better, so don't just watch me with the video. You can pause it until you're ready to go, or go forward. So the left side hopefully is easy. We have the square root of something squared. Well, that just means whatever's under the radical is going to be what we're left with, x squared minus 8. This right side is x minus 2 squared. That's where I was talking about remembering your special cases. If I have x minus 2 squared, it's x minus 2 times x minus 2. So I will have this middle term of 4x. So the right side becomes the first term squared. Negative 2 times negative 2 is positive 4. And then my middle term will be a minus 4x. If you're forgetting how to multiply binomials, jump on back to week 6 and 7 and find some good video there. Okay? And then solve. Solve this equation. So some of the tools that we have to solve is set your equation so it equals 0. Because then we could factor and use the zero product property. So I'm going to subtract x squared from both sides. I'm going to make sure I keep my equal signs lined up so I don't make silly mistakes. So I subtract x squared from both sides. I also don't want that minus 8. So I'm going to add 8 to both sides. Keep my equal sign going. So I have 0 is the same thing as negative 4x plus 12. I don't really need to factor, and I don't really need the zero product property in this case. I'm now down to just a single x, a linear equation. Well, in this case, to isolate the x, I'm going to subtract 12 from both sides, and then I'll divide by negative 4. Again, writing down each step as I go. This coefficient of negative 4 being multiplied by the x is blocking my goal. That's why I divide both sides by the negative 4, and I find out when x is 3, my equation will be true. I'm going to do a quick check. My original equation was x squared minus 8. Square root of x squared minus 8 is the same thing as x minus 2. So if I now have a 3 in both of those places, then it would be the square root of 3 squared minus 8 is the same thing as 3 minus 2. 3 squared, 3 times 3 is 9. 9 minus 8 is 1. The square root of 1 is 1. And 3 minus 2 is 1. So yes, my original equation is true. So that means x equals 3 is the solution to the original equation. Again, you can pause if you need to. Take some time, make sure this makes sense. This is the goal for the week. This is it. Week 10 gets so much easier. And then week 11 is even easier. So you're in the home stretch. Weeks 8 and 9 have been challenging. Week 8 is a lot of new notation. Week 9 is solving absolute values. But do you notice the similarity between week 9 and week 10? In week 9, I asked you to isolate the absolute value, and then you rewrote it as two equations. and solved each of those two equations to find your two answers that made the original equation true. Now in week 10, step 1 is isolate the radical. And then after you isolate the radical, do what you want to both sides to get rid of the radical. And then you're back to solving an equation like we've been solving for the last 10 weeks. You'll either set it equal to 0, you'll factor it, you'll do whatever you want to both sides of the equation until you get that x isolated all by itself and a number on the other side, and then you know that is your solution to the original equation given. So you'll be doing something like this for your discussion this week. Make sure you read the directions. Okay, let me show you a few. That's what it's going to look like. All right, let me do a couple more examples here from week 10. Again, solving for u. This is a fourth root of u. It's this 4 right here that tells me that's blocking my goal. So I'm going to raise it to the 4th power. So u is the same thing as -4 to the 4th power. Well, that means I've written something down 4 times. And this -4 is what I'm multiplying 4 times. Negative times negative is positive, so that would give me positive 16 times positive 16, and that's 196. So that would be my answer. That would be the number that I could plug in there and get a -4 out. Is that true or false? Is the 4th root of 196 going to equal a -4? And the answer is no. I have a negative output. How can I have a negative output? If I am multiplying 4 negative numbers together, negative times negative becomes positive, and negative times negative would become positive. And if I'm multiplying positives, I will end up with a positive. Because this index is even, I cannot have a negative answer. If the index is even, we cannot have a negative output. I'll say negative answer. Now I'm going to say negative output. If you grab your calculator, well, anyway, it's not going to work that way. All right, again, the index is this one. That one right there is the index. It's whatever the n is in our radical. All right, so the answer to this problem is there is no solution. There is no number in the universe that if I take the 4th root, it will come out and be negative. All right, this one we've done before. This is our index of 3. It's blocking our goal, so I cube both sides. Notice I put parentheses around both sides. 3 times 3 times 3 is 27. Again, we don't multiply the base and the exponent. The exponent, this exponent tells us how many times we multiply the base. All right, Here we have v to the negative 1/4 power, so we can raise it to the 4th. It's the one we just did. We would end up with v is 196, but if we plug it back in, we would find out it's not possible. We cannot take the 4th root. New thing you're learning this week, v to the 1/4 power is the exact same thing as the 4th root of v. Because these are the same, you can use whichever one you want, and we've already done that problem. All right, let me get to a few more and more complicated. Word problems tend to be pretty straightforward. We're asking you just to, do you know how to use the square root function or the nth root function on your calculator? Here, what's being asked of you is, what is the 4th root of 256? I want to show you quickly how to do that on your calculator. You will not be allowed the computer calculator on the exam, but you will be allowed your own calculator. All right, so using your calculator here, there's a button that I want to make sure you're aware of. X squared and square rooting are inverse functions. The same way, if I have x cubed and cubing, they're inverse functions. X to the y, how that works is if I type 6 and then 2, the first number I type is the x, the second number I type is the y. I messed it up here for a second. And that would be the square root of 6. That means 2.4494897 squared is going to be the same thing as 6. All right, keep the questions coming. Let me know as you have difficulties, and I look forward to helping you succeed.